Hi, everyone. Welcome to the Art of the Possible series. I'm Nihali Niyogi, and I'm Principal Cloud Solution Architect at Microsoft, focused on advanced networking. And in my role, I work with diverse set of networking partners, ISVs, SIs, system integrators. With me, I have my co-host Cynthia, whom I have been working closely with over the last 6 months or so to cover some borderline cross-functional networking areas, if you will, and collaborate with our ISV partners to provide more insights into partner integrations. Today's topic, as you can see on my screen, is about M365 network connectivity principles and tooling to improve and gain insights into the end user experience. And then we are also going to talk about informed um, network routing. So this was the network connectivity principles, and this is the informed network routing that provides deep integration into with our SD-WAN partners. The target audience for this session is network architects and M365 administrators, and we also have a diverse audience in our panel today. So thank you everyone for joining. And lastly, we have two amazing speakers, Jeff and Roshan, who are both program manager and architects from our M365 core team. So let's go through a round of introduction. Tell us more about your background. Cynthia, I'll start with you, and then Jeff and Roshan. Welcome.
Yes, thanks, Thank you, Nihali. I'm part of the Azure Networking Global Black Belt team that I joined 3 years ago. And before that, I spent 20 years in the telco industry working for service providers. And with Nihali, we've been working together on an ISV series and managed offers in Azure. This session is more on the SaaS side and not on virtual WAN, but still on networking and SD-WAN, which is a topic close to my heart because I've spent probably the last 5 years in my previous role working on migration for customers to SD-WAN.
Awesome. My name is Jeff Mielef. I'm a principal product manager and architect in the Microsoft 365 core engineering team. I've been with Microsoft for, I'm actually just coming up on my 25-year anniversary in various engineering roles. I actually spent about, I don't know, probably about 8 years in kind of a field and customer-facing role, helping customers with, large enterprise customers with challenging problems, many of which were network related. But in my current role, I help to manage most of the Microsoft run infrastructure that delivers M365 to our customers. And I work directly with many of our ISV partners around some of the integration that Nihali mentioned with regard to informed network routing.
Hey, I'm Roshan Sabapathy, product manager with the M365 core team with a mix of experiences in the field, customer-facing roles, and presently in the engineering team. I focus on customer network connectivity features and tools that help our enterprise customers to make the right network connectivity choices when they send network traffic to Microsoft 365 services.
Awesome. Welcome, everyone. With that, I would say, Jeff, take it away.
Okay. Hopefully you can see my presentation momentarily. Let me know when it appears.
Yeah, we can see it.
Okay, great. So let's go ahead and jump in. So today we're going to be talking about things Nihali already introduced. We're going to go through some detail about some of the tooling that Roshan works on to help our customers understand their particular connectivity architecture and how it's related to the work that Microsoft's doing to bring the cloud closer to our customers and how they can improve. We're going to be talking about some of the investments that Microsoft's making around making that easier in terms of the the data that we provide to customers through various means to understand what the sort of surface area of our cloud services look like, and they can then use that information to optimize connectivity. And we'll be talking about the informed network routing integration that we do with some of our SD-WAN partners. But before we get into that, I think it's important to level set and help you to understand, I think, why we care so deeply about this space and why connectivity is so important to get right for our customers and partners. So as we think about the move from traditional on-premises deployments of productivity tools, which is generally what we think of in the Microsoft 365 suite, to hosting those services in the cloud, one of the biggest differences that our customers face is the connectivity path between the devices that end users are consuming those services from and the place where the data lives and the compute is happening. In the previous world, customers were solely figuring out what that connectivity path looked like and what the deployment architecture was of those services within their own data centers. Today, that's very, very different. With Microsoft hosting those services, or really, frankly, this what we're talking about today is generically applicable really to any SaaS service. SaaS is made available everywhere. There is no sort of specific location where compute happens, or in many cases, even specific location where data is stored. For availability purposes, this is spread out all over the globe. And, obviously within the boundaries of compliance restrictions. But the key point there is Microsoft, or whoever the service provider is doing whatever it takes to provide the highest availability possible and the highest performance possible for these services in order to deliver them at a same or better quality that our customers were able to achieve by hosting these services within their own networks in the past. When we think about how that's done, Microsoft is making a huge amount of investment on our side in terms of bringing the cloud closer to our customers. And what we're talking about there is what we refer to as the first mile. That's the section of Microsoft, or sorry, the section of sort of SaaS infrastructure broadly that Microsoft controls. That's the stuff we have the ability to influence. That's our data center investments. That's our network peering investments, our WAN investments in terms of the connectivity between those data centers and peering locations, and the relationships that we have with middle mile ISPs and other network service providers in terms of where we peer with those providers and how we provide high availability from a connectivity perspective with those providers as well. And then it's also the architecture of our services in terms of how we deal with traffic management, how we get people to get our customers to the best possible location on our network to service a request. Again, optimizing for high availability and performance as we make those decisions. On the flip side, our customers have a huge ability to influence the experience that they're going to have with our products in terms of the portion of the infrastructure that is either within their premises or is based on choices that they make when they think about the services that they're consuming from ISPs or other network service providers that impact the connectivity path to the edge of Microsoft's network. And the combination of Microsoft moving the cloud closer to customers, as well as customers making the right choices with their network architecture to be able to take advantage of those changes that Microsoft makes, is what adds up to that great experience and really what drives down latency for these requests that our clients M365 client applications are making to the cloud. And that's what really drives that experience. So again, it's really all about trying to optimize the path from the end user device to the edge of Microsoft's network and sort of meet in the middle and take advantage of these benefits. So to help enable that, a number of engineers at Microsoft, including Roshan and myself, got together a number of years ago and tried to create a set of simple connectivity principles that are very easy to understand for our customers as well as our ISV partners that will drive the right behaviors and architectural choices to be able to take advantage of the work that Microsoft is doing on our end in the first mile. So I'm going to briefly go through these, and then hopefully you'll see how many of the investments that we're making from a tooling perspective help our customers to actually achieve these principles as we go through the session today. So the first principle is really about identifying Microsoft 365 traffic that is flowing through a customer's network. And that's done primarily through a taxonomy that we provide. And we do this with, sort of semi-static documentation that exists on the web, but we also do it via a web services endpoint that can be used for automation or integration with ISV appliances that describes all of the endpoint, basically all of the surface area that makes up Microsoft 365. You can think about this as the FQDNs that are used by clients to connect, the IP addresses generally for the services that are hosted within Microsoft data centers, and that can be used again to identify the traffic that is Microsoft 365 or isn't, and then treat that Microsoft 365 traffic differently. Again, differentiate that traffic from generic internet traffic, and ensure that it is following an optimal path to the edge of Microsoft's network. Now, historically, our guidance to customers was something along the lines of, get that traffic out as quickly as possible to the internet and don't proxy it, which is sort of naive to say for this gigantic set of traffic that includes things that are going to CDN providers that Microsoft doesn't control. There's endpoints in that list that are needed for optional features like integration with Facebook or YouTube that our customers clearly want to treat with a little bit less trust than they would their sort of core Outlook or SharePoint data path traffic. And so we very quickly realized that we needed to be much more granular. And we have three categories of traffic within that taxonomy: optimize, allow, and default. And we provide some specific details around how you should think about that traffic. Optimize is the category that's most critical to get out to the internet as quickly as possible with the least amount of interference possible. Ideally, that's direct and local. Allow is sort of the middle ground. That's still more trustworthy hosted in Microsoft traffic, but less latency sensitive. And so if you need to apply some security policies or something to that set of traffic, that's likely going to be just fine. But again, in terms of our guidance, we'd prefer that is direct and local as well. And then there's the default category, which you should treat as generic internet traffic and feel free to apply whatever security policy is necessary. So that's the optimize pillar. Enable local egress. This is about ensuring that there is a path out of the local branch, essentially, to get that optimize and ideally the allow traffic out to the internet as cleanly and quickly as possible, so it can peer with Microsoft in one of those many hundreds of peering locations that we have around the globe, and have that traffic handled as optimally as possible with the least amount of latency possible. And it's important to understand that requires matching DNS resolution as well, and that's for our traffic management algorithms, so that we can correctly identify where that traffic is coming from and handle it in the closest possible location. The third principle is around direct connectivity, and this is about avoiding what we refer to as network hairpins. So if we're not doing direct and local egress, there are scenarios where we see customers adding sort of unnatural directionality to traffic. And you could think of this as passing the traffic through perhaps a security appliance or a secure web gateway product, where whatever that product is, might be cloud-based, might actually exist in a customer data center somewhere else. What we end up seeing is that traffic takes a path that adds a significant amount of latency to get to whatever that appliance or product is, and then come back to Microsoft's network to actually be serviced. We want to avoid that wherever possible and minimize the impact of those hairpins. And then the last pillar is around modernizing security. And this is about understanding that there are security features a very significant number of security features that are actually built into the Microsoft 365 suite to provide very advanced visibility to what users are doing in near real time, as well as a number of features that align very nicely with zero trust policies that our customers can take advantage of in order to actually replace and enhance some of the things that they would have done with a traditional network, or I won't say traditional, a legacy network architecture, where you may have products sitting on your network that are trying to reverse engineer what a user is doing with one of these productivity applications. What we find is that the ability for being able to reverse engineer the intent of a user by doing sort of protocol analysis on the wire is sort of the ability to do that properly diminishes over time. Our protocols constantly change. The way in which services interact with each other constantly changes. And our approach is to say, let's provide from a Microsoft perspective our best visibility into what's actually happening on the network in ways that both customers and ISVs can consume, and do it with the right granularity, such that we can actually replace the need for products that can't really do it with in a reliable way by looking at data on the wire. So that's really about modernizing security, and I think the zero trust movement that we see in the industry is really aligned with what we're talking about here as well. So those are the four connectivity principles, and I'm going to hand it off at this point to Roshan to talk about what we're doing from a tooling perspective to align to those principles and help our customers adopt them.
So, excuse me, Jeff, real quick, couple questions here, if that's okay.
Sure, please.
So, you talked a little bit about direct egress and how local egress is preferred. Could you talk a little bit about the guidance around express route? That's often a little confusing for our customers. I know the guidance has changed. Maybe you can talk a little bit about that.
Sure, absolutely. So ExpressRoute, for those who aren't familiar, is a product from Microsoft that provides, you can think of it as well, there's two different flavors of ExpressRoute. There's a private connectivity flavor of it that you could think of as being more aligned to Azure infrastructure as a service deployments. And there is a sort of Microsoft public internet style peering associated with ExpressRoute connectivity that's more aligned to consuming SaaS services. ExpressRoute is a fantastic solution for consuming IaaS services with Microsoft. And I say that because in general, when you think about one of the key differentiators between IaaS and SaaS, with IaaS, a customer is designing compute and non-compute and connectivity infrastructure in a similar way they would have done historically with their on-premises deployments. They're specifically picking locations where all of these activities are going to occur, and they're specifically designing network connectivity between those locations to enable the scenarios that their business needs. And ExpressRoute is very much a point-to-point connectivity solution. You're picking the specific locations within the customer infrastructure that's going to be one end of the ExpressRoute connection, and you're picking locations within Microsoft's infrastructure where that circuit is going to terminate and exchange data with the customer network. Again, because it's very much focused on specific locations where hosted infrastructure for the customer is going to exist, you can optimize that connectivity path to be aligned with those locations. In a SaaS world, again, where SaaS is effectively everywhere and the endpoints that are used to consume our services are everywhere, that makes less and less sense. And what we find with customers using ExpressRoute is that typically you end up not really getting a benefit over just sort of generic internet connectivity or some of the more enhanced internet connectivity options that we partner with our ISP friends to provide. And instead, what you actually end up with in some cases is a degradation in availability, because you end up with some single points of failure for your connectivity into Microsoft's cloud as a result. And the other key point is that not all of Microsoft's M365 endpoints are actually available over ExpressRoute. And so internet access is still required in order to consume our services, in addition to the ExpressRoute sort of overlay on top. And based on that, we have a very strong recommendation for M365 SaaS services that ExpressRoute not be used. And as a result, there's actually an approval process that's necessary to go through to make sure that our customers aren't, coming into this making a bad choice and perhaps spending resources unnecessarily to procure ExpressRoute for this purpose.
Awesome. Yeah, great points. Thanks, Jeff. And your previous slide, I really loved, as a network engineer, I really loved your previous slide. If you wouldn't mind going back to it, I had one question about that. I work with a lot of service providers. In fact, last week I had a engagement with a LATAM in Latin America. Is that middle mile where a service providers could leverage our Microsoft peering services to enhance that performance?
So we think of the middle mile as anything sort of beyond the edge of the customer's network and the sort of edge of our peering infrastructure on Microsoft's network. In terms of the Microsoft peering service, basically the answer to your question is yes. We would encourage any ISP to take advantage of the Microsoft peering service and work with our partners in Azure to onboard to that. Microsoft peering service from a Microsoft 365 perspective is great for a number of reasons. I think from our perspective, it's super useful because it drives high availability in terms of having a diverse set of peering connections for a given ISP across Microsoft's network. It provides the ability for the end customer to actually be able to get some optics, some observability into the performance of their connectivity into Microsoft's network, and it just sort of strengthens the notion of consuming what you might think of as generic internet connectivity, but in a way that is much more appropriate for enterprises to consume these critical services for their business.
Got it. Thanks, Jeff.
Yep.
Yeah, so no other questions. Yeah, no other questions. You can proceed.
All right, I'll hand it off to Roshan.
Hey, thank you, Jeff. It's always great to talk about the network connectivity principles. I still find this, standing the test of time. It is the moral compass. It's the guiding compass when it comes to making the network connectivity choices for our customers even today. So before we jump into the network connectivity features and tools, I wanted to call out a significant investment from Microsoft. This is called the Unified Domains Initiative, and this has got a lot of relevance to how customers connect to our services. We have received consistent feedback from our enterprise customers to simplify the list of domains used to connect to Microsoft 365 services and to set some higher standards for security and domain reputation. This is necessary for our customers to treat Microsoft 365 traffic with a certain level of trust. Jeff touched on this while discussing the fourth connectivity principle, especially the recommendation around not breaking and inspecting the Microsoft 365 traffic at the network layer. So in response to this customer feedback, to simplify the list of domains, we have invested in unified domains for Microsoft 365 services, mainly star.cloud.microsoft, being the dedicated domain for Microsoft 365 services, And this is a significant investment from our side. And with this investment, we are able to make customer promises like everything hosted in this domain will require user authentication. So that means anonymous access should not be possible. There will not be any third-party services or IaaS or PaaS type of services hosted in this domain. We also have two additional domains, start@static.microsoft and start.usercontent.microsoft. That's dedicated for scenarios like user uploaded active content. That's typically untrusted content. And these two domains remain isolated from start.cloud.microsoft. So as you can see, we have set a higher standard for domain security. And we are also improving the domain isolation to gain customer trust with dedicated domain like start.cloud.microsoft for connectivity to Microsoft 365 services. This is an effort across all our engineering teams at Microsoft 365, and we have been working hard to accelerate the shift to start.cloud.microsoft. And going forward, you will see more and more services being hosted in this domain. Some of our marquee products, including Enterprise Copilot, are already hosted in this trusted domain, start.cloud.microsoft. So let's dive into the features and tools we have for you today. For Microsoft 365 tenant admins, there is a place in Admin Center to visualize the impact on your end users due to network connectivity choices made by your organization for sending the end user traffic to Microsoft 365. This place is what I'm referring to as customer network connectivity in Microsoft 365 Admin Center. You can go to this place by directly accessing this URL. You can see this is also on admin. This is also on cloud.microsoft. You can access this by with this URL directly, or you can navigate to the network connectivity page under Health in the Admin Center. So Jeff already set the context here with this drawing, and this drawing really illustrates the end-to-end path between your end users and Microsoft. And the path, as Jeff explained, is divided into three conceptual miles: the first mile, middle mile, and the last mile. And the first mile is really the Microsoft Global Network. We spend a lot of time and effort expanding this network to bring this close to our customers. What we are going to focus on today is not on the first mile. We are going to focus on the last and middle mile, which is what is typically called as the enterprise last mile, because as Jeff mentioned, this is where you as a customer have control over your network, or at least you can influence the connectivity choices made in the last mile or in the middle mile to ensure they align with our network connectivity principles. So in this drawing, we have zoomed in to take a closer look at the enterprise last mile. This allows us to take a look at what we are testing, how we detect network issues, how we detect insights and share them with you, and how we help you align with our connectivity principles. So I want to first call out a couple of things in this drawing. The first mile that you saw in the previous drawing is still there. It's just shrunk and it's just moved to this top left corner. So that's the Microsoft first mile. And what you really see in this drawing is you've got my head office, which is users in head office. This is a location, and the traffic from this head office travels through this enterprise last mile, and it goes through this network perimeter, or the stack of devices, which we often refer to as the security stack at the network perimeter. So it passes through this network stack, it passes through the enterprise last mile, it gets handed off to the ISP, and from the ISP, it's on to the Microsoft network. You may also have users in outside your head office. So like users in hotel or in a coffee shop, they're also connecting to the enterprise last mile. They're using additional links like VPN to connect back to this enterprise last mile. So they come into the head office, they go through the same enterprise last mile, same central stack of devices at the network perimeter, and then they go on the ISP and the Microsoft network. You may also have users in branch office, as we see in this bottom right here, and users from the branch office also need to use additional enterprise last mile. So this is, typically what we call as the backhaul, network backhaul, or backhaul of traffic, because we're bringing the traffic from branch office to the head office, and they go through the same path as the head office users before they go onto the Microsoft network. So which means the users in branch office may have a longer path, they have more latency, they may have a different experience to the users in the head office, and the same is true for users in the hotel or the coffee shop, because they also have a longer path. They have a kind of a bottleneck, which is the VPN. So they may have a different experience when compared to the users in the branch office. And if you compare all of this with the user, a typical user like a person or a consumer working from home, they don't go through all this long paths with higher latencies and bottlenecks. They just have a direct connection to the ISP, and then they get on the Microsoft network as quickly as possible. And so their experience is going to be very different to what the user experience is in the head office, the branch office, or any of these other locations who are using the enterprise last mile and the network perimeter. So I think the main call out here is that in the enterprise last mile, you've got different locations like the head office, the branch office, and those locations may have different experiences, and they may have to take a longer path. They may have to go through a central stack of network devices, network security devices. It's important for the Microsoft 365 tenant admin to understand what the experience for the user looks like at each of these locations, the different locations. And it's also important to understand why the experience is different for a user in branch office because of the connectivity choice they have made, and why the experience may be different for a user in hotel or a coffee shop because of a connectivity choice like a VPN backhaul that they have made. So this is really what we try and represent in the admin center. So we want to represent a couple of things, right? We want to represent your network perimeter location, because end of the day, this network perimeter is a physical location. It can be a customer data center. And in the recent years, you will notice that things like proxy server or a secure web gateway have moved to the cloud, which means that could no longer be in the customer data center. So that could also be in a cloud data center. So this is all about we need the physical location of this network security stack, and we also need to identify the user location if possible, because ultimately, if we know the user location, then we are able to tell you if the branch office users are having this additional length to travel the distance, right? So we need the network perimeter location, we need the user location, and we also want to detect who the network provider is. Like I said, if you're using a cloud proxy provider that's providing you the service, we also want to detect that. We want to show you, along with the perimeter location, who is the network provider responsible, for the performance that your end user is getting, right? So those are some key things that we try to represent in the admin center. So let's go take a look at what those look like, and here are the details about the test, right? So when we do these network tests, there are there are a couple of things to keep in mind, right? We don't do unnecessary tests. This is not about real-time troubleshooting or debugging. This is about collecting the bare minimum information, keeping the test lightweight, and collecting only the necessary information for us to represent your user experience in the admin center. We do not collect things like device ID or user ID. We do, however, have things like the tenant ID, because that helps us to associate the test results with your tenant. We do different kinds of tests, like including tests for things like Enterprise Copilot, where we can check if the underlying network can support WebSocket. We can do latency test or download speed test for SharePoint, and jitter and packet loss type of test for Teams. We aggregate the test results, and then we aggregate them for your tenant, and we aggregate them for your user locations. If we cannot identify your user locations, then we aggregate them to your network perimeter locations. Network perimeters can be detected quite straight. It's a straightforward detection for us, because we do see the public IP from where we receive your traffic. So we can use that to detect your network perimeter location. Whereas the user location is a bit tricky for us to detect. There are a couple of methods. You can enable for us to detect that. But if you don't enable any of the methods, that's totally fine. Like I said, we'll still detect your egress location, and we'll aggregate the results based on your egress location. And if you're using a cloud proxy provider, the edge or the network egress point that we detect for you, or the network perimeter point that we detect for you, is the cloud proxy edge, and not your data center edge that you manage directly. Also, we detect the different kind of network providers responsible for providing you the service. I mean, ISPs and overlays. What we mean by overlay is like a cloud proxy provider who is providing an overlay service on top of the underlying transport, which is provided by the ISP. At the end of the day, the network insight is basically detected for a specific office location, or a location where your users are connecting from. By insight, we represent that as a combination of issue and a solution. So let's go take a look at some of this. And these are the three methods by which you can specify the user location. Like I said, some users, some customers use Windows location services. If you enable location services on the devices, we are able to get location information along with the network telemetry. And that's approximated. The location information is approximated to 300 meters. And we can detect it this way, but some customers may not enable this by policy, which is totally fine. And also, if you've got, let's say, multiple offices within the same city, this may not be a good method, in which case you can use the LAN subnet ID method, wherein you actually define the locations by using the LAN subnet information, because these are essentially private IP ranges that you have allocated for your offices, and you can define the different office locations by mapping the LAN subnet IDs for every location. And you can even name the offices. You can totally customize it. If you already have this information in some format like a CSV, you can import that, and you can also export the data from our admin center. And the last method here is the network connectivity test tool. We'll talk about this test tool, but essentially this is, when you want to test this from a specific location, you can ask the user to go to our connectivity test tool, which is accessible from a web page, and you can ask them to go there and run this test from a specific location, and then that would upload the results to the admin center, and along with the results, the user can also specify the location. So that's the manual method of doing it, and these are the three methods for the user locations. If you don't specify the user location, like I said, it's not a deal breaker. We will still detect your network perimeter location, because we do see the public IP from where your traffic is coming, and we can base our insights based off the network perimeter location. Okay, so this is what the admin center page looks like. So if you go to network connectivity in admin center in the health section, this is what the landing page looks like. There's a ton of useful information in here. Quick callouts. These dots represent the different office locations we can detect, for your tenant. If we cannot detect end user office locations, we will represent the network perimeter locations, as I just explained. The color of the dots really, represents the assessment of the location, because if it's green, it's a very healthy assessment. If it's not green, it's not so great. It's not so great or not so healthy. The size of the dots represents the number of users we detect in every location, so that's correlated with the size. Now, there are two things that you can take away when you come to this page, right? So as a result of doing all this tests, we give you back two things. The first is in the form of network assessments, right? So we give you a set of numbers. Like we can tell you what the latency is for a user in your head office. We can tell you what the latency or a download speed is for your user in the branch office. We can tell you what the team's jitter or packet loss looks like for a user who is connecting through a VPN link, and what they are experiencing. Now, for things like Enterprise Copilot today, we can tell you if WebSocket is supported, from your different office locations that we are able to detect. For star.cloud.microsoft, which is the most critical domain for connectivity, we can tell you if users are being blocked from accessing or connecting to that domain. So these are tests that we run, and these are things that we can tell you. So there are some form of results that we present back in an assessment. So latency, download speed, jitter, all of these are numbers. We can put that in the form of direct network numbers. We give it back to you, or we can assign points based on the results. For example, we can assign points for Exchange out of 100. We can assign points for SharePoint, and we can do a total of those, and we can present to you the overall picture at the tenant level or at the location level in the form of simple assessment points. In this case, you can see the tenant has 82%, which is 82 of 100, which is really an average of all the 4 workloads, Copilot, Exchange, SharePoint, and Teams today. We give you the history. We also show you the network providers. So we can detect, who are your ISPs, who are your overlay providers, like cloud proxy providers, VPN solution providers. We show you that as well at the tenant level. So we show all of this at the tenant level, along with the history information of how your network assessment at the tenant level looks like over a period of time. Now, here is the network traffic tab, which basically gives you the tenant level view of your network provider specifically. And this is the same thing that we showed you on the overview page, but you can take a good look at the network traffic page, which is dedicated for the network providers. The reason we did this is because customers' feedback was to show them network providers that are responsible. Show me the ISP responsible. Show me the overlay provider, like my cloud proxy provider, who's responsible for this performance. So this is what we do here. We take all those test results, we aggregate, and we show the performance attributed to the network providers. You can see here that the ISP has got a better performance than the overlay provider, like this particular cloud proxy here. And they've got a slightly lower performance when compared to the ISP. So this is, all about network provider performance. And you can do things like you can dig into each provider. You can see, for example, what are the locations where I'm using Contoso ISP? What are the locations where I'm using Fabric and Cloud Proxy? You can do all of that from this page. Now, the reason this is important is if you're a big global company, you just don't have a single network perimeter, right? You have multiple network perimeters distributed across your continents or different countries where you're present. You may have a network perimeter in Singapore, and you may have a network perimeter in the West US, which is very different in terms of the ISPs or the providers that you may be using, and the policies that you apply at different perimeters may also be different. So that's one of the reasons, we started providing the network provider information for along with your network perimeter assessments as well. As I was saying, you can double click and you can look at a particular service provider. You can look at the locations where the service provider is being used, all from the same page. You can jump to the locations, different locations from within the same page here. Now, this is something that we introduced very recently. We spoke about the Unified Domain Initiative, start at cloud.microsoft. And one of the things customers ask for is, they need a clear picture if, their users are able to connect to these critical domains like start at cloud.microsoft or static.microsoft. And they also want to know if, WebSocket is permitted in the underlying network. Because if the user cannot use WebSocket, then that means they cannot connect to services like Enterprise Copilot. So this is an ask from customer, and we wanted to make it as simple and easy for you to understand this. And this is one of the information that we show today in the admin center. And if you've got a high error rate or a block rate, then we are going to trigger a network insight for you. And we'll give you additional information like the locations impacted, the network provider responsible, so you can go and take some actions immediately. This is the location page where we've got the different locations automatically detected for you. And a couple of quick callouts here is, if you've used one of the methods to give us the location using Windows Location Services or using LAN Subnet ID, then these locations represent your end user locations. If you have not taken any action to give us the location information, which is totally fine, then we will automatically detect the locations, and what these locations represent is your network perimeter locations or your network edge or egress locations, as we call them. For example, in this, you can see here, this icon is a little bit different to the rest of the icons, and this icon for Johannesburg represents the location which has been created manually using the LAN subnet ID information. So the admin has went and created a location, and they have provided the LAN subnet IDs associated with this particular branch office in Johannesburg. And that's why we have this drop-in icon. And whereas the rest of the locations were automatically discovered either through Windows Location Services, which has been enabled for this tenant. And you can also see that some of these locations may have submitted user reports here in this last column. What this means is somebody has used the standalone tool or the network connectivity test tool, which we'll talk about shortly. So they've used that tool to submit a report, and they've signed in to the tool when they ran the test. So that's why the admin is able to see that here for this particular location. Okay, so I showed you different pieces in the admin center. Now to the network insights. Like I said, I mean, the two forms of takeaways for you when you come to admin center. The assessments like performance, latency, download speed, all of that is good to have. But they are not necessarily, things that you have to act on immediately, because those are things that you monitor over a period of time. And if something drastically changes, then you may have to take some actions based on that. But here are, the examples of network insights that we detect today. And these are, things that you really need to act on, because a network insight, like I said, is a combination of a detected issue and a solution. So what this means is a user can have significant pain or significant user experience impact due to this detected insights. So the example here I'm showing you is, when let's say some of your users are blocked to connect to domains like star.cloud.microsoft, static.microsoft, or usercontent.microsoft. So that's, that's an area that can cause a lot of pain, and we want to detect that. We want to show that as an insight along with the solution as to how you can resolve this insight. Now, this is all shown under the Insights tab, and these are the 3 types of insights that we detect and show for you today, and this is one of them. And we also give you the ability to drill down into this insight. For example, you can click on one of these locations from within this flyout, and you can see some additional details like what is happening at that specific location. What's the percentage of samples, or what's the percentage of connections that are being blocked for users in this location. So you can take a look at all those details from within this flyout. We'll give you the network provider details as well within this, or in the locations table, where we'll show you the network provider responsible for this particular block. So with the location, with the provider information, with the percentage of connections blocked, I think you have got all the information at hand to take some remedial action. So that's the whole point of sharing this insight, so you can go and take some actions with the information provided. Here's the second type of insight. WebSocket connections for critical Microsoft 365 domains is failing. So this basically means your underlying network does not support WebSocket. So this can impact Copilot, enterprise Copilot scenarios. So this is another type of insight we detect, and we show the locations, we show the providers, we show the percentage of blocked connections. So all of that gives you the actionable information to take actions. The third type of network insight is when we detect TLS break and inspect for connections to Microsoft 365 services. So once again, as we mentioned, we do not recommend TLS break and inspect, and especially with investments like start@cloud.microsoft, there's no reason for you to do that, and it's one of our connectivity principles as well. So that's the type of insight we want to detect and we want to show you. Once again, we show you the list of locations where this insight has been detected, along with the network providers, so you can go and take the actions. We also show you the impacted workloads, due to this particular insight. So these are some references that we have provided. So if you want to go ahead and add an office location manually, we spoke about the LAN subnet ID method. So this is the way to do that. You can go to the locations, you can use this add location, or you can use this manage multiple locations method to add office locations or to import office locations from a CSV file. You can name your office locations. You can drop a pin to a city, and you can add your LAN subnet ID ranges for these office locations. The important call out here is you can specify a supernet, which means you can specify something as wide as /24, even though you may have like multiple smaller subnets within the /24. So you don't have to go and specify all the smaller ones. You can just use a wide one like /24 or even a /16, and you can just specify a wider LAN subnet. This is what the location-specific assessment looks like. Just taking an example here of Redmond, Washington, and you see the same assessment details that we saw in the previous tenant-level assessment. It's just that this is specific to Redmond in this case. So when you go to the details part in the location, that's where we show you all the attributes we collected, all the tests that we ran. So all of that information, all of that good details are present here. The most important call out here is that you can see that we present you a set of results for the location itself. Like what did we detect for this location? We then give you the results for Exchange, for SharePoint, for Teams. And then, if there are connections blocked, we, show you that as well at the end here. In terms of the columns, you'll notice that 3 columns, and the collected samples. What that really means is this is the test results that we are receiving, and these tests are run from the Microsoft 365 apps. They run in the background. Like I said, these are really lightweight tests, and that's what we mean by collected samples. If the user goes to the network connectivity test tool and if they manually run the test, then that's appearing here. That's user submitted results. And we also detect and show the test results for remote workers. And this is basically people who are working from home, and we are able to detect them as well for your tenant. Okay, so these are the new things that we introduced recently here. So when we look at the network details for a specific location, you will notice that in addition to Exchange and SharePoint, we now show things like Microsoft 365 Copilot. So we want to show you the assessment for Enterprise Copilot, what the latency look like, whether the WebSocket is being permitted, or if you've got a higher error rate, this green tick will typically not be there. You'll probably see like something else, which basically denotes that there is an issue. We also show you the block rates for the unified domains like star.cloud.microsoft. So that's another thing to pay attention to here. And the rest of the details for workloads like Exchange, SharePoint, and Teams, which are always useful. If you want to take a look at that, that's also available here. Right, so the last part I want to cover here is the network connectivity test tool. Like I said, this standalone test tool. Now, imagine if you don't have Microsoft 365 apps installed on your devices, right? So you still don't have users with apps installed. Then how do you assess your network, right? So that's the reason this tool exists. Like you can direct the user to go to this tool, go to this link, and they will be able to run this tool immediately, and they will be able to upload the results, and the results are also available to you immediately. So this is really a standalone tool that anyone can access and use. A couple of downsides for this tool is that this does require .NET framework, so it does require .NET to be installed, and it requires an executable to be downloaded by the user. And some of these, can be a problem at times if the user doesn't have the right permissions, etc. But this is the landing page of the tool. We also introduced a new test for Copilot specifically. So this one actually tests the things relevant for Copilot, like WebSocket, the latency, and it gives you the details of the test results. Or you can run the full capability test by using this run test option. And when you do that, there's a lot of tests that we run. So as I'm showing you here, there's a executable that you download, and when you run that executable, it basically runs a bunch of tests, and then it uploads all the results. And you can then view the results in the details pane here. And once again, we collect a bunch of information. We do some additional tests within this tool. For example, we do things like VPN split tunneling tests. Like if you've got VPNs, agents, or adapters installed on your device, and if you're routing traffic based on VPN paths, then we can detect that. We can show that to you. We can show that here. We also detect if you've got a proxy. So there are some bunch of additional tests that we run with the standalone tool. It's really useful. It's really quick because if you are having some troubleshooting, or you're doing some debugging, you are supporting some user help desk tickets, then this is a tool that you can use to quickly go and run and see what the current status of connectivity is, for that user from the location where they are in. So there's lots of information as usual we share in the details pane based on the tests that we run for Exchange, SharePoint, and Teams as well. And that's the complete the end of the the test that's been run. The one thing that I highly recommend is for users to sign in when they go to this tool. When you sign in with your tenant credentials, your work credentials, then what that means is you can share this report with your tenant admins. So you can also share that report by using this copy link option. All right. So these are some useful features that get enabled only if you log in. So we highly recommend users to sign in when they go run this tool. But you can run this without signing in, and you can run this anonymously as well. So that's possible. With that, I think we covered the tools, and I'll hand it back to Jeff for informed network routing.
Great, thanks, Roshan. So yeah, actually, Nahali, you've got a question. Before it.
Yeah, couple questions. First of all, fantastic insights, Roshan. So there's the great view of the results. So I'm thinking, from three different personas. So we have this end user, we have this tenant admin, we have this network architect, right? So we have three different personas. I'm thinking if I have to summarize, what we would like an end user to do versus because of the way the location services, people may not want to turn it on, and it almost seems like with everyone working remote, the data may be skewed if most users decide not to turn that on. In your experience, like how do we get that data to be as accurate as possible? What is a go-do for our end users, I would say?
Yeah, great question. So the admin center piece is definitely, for the tenant admins only. So that is accessible only for the admins. Now for the end users, the standalone tool that I showed, the connectivity test tool that I showed towards the end of the session. So that's the most useful tool for end users, because that's the one they can go and access from the web page. Now, as far as the test results and the optics are concerned, the optics are enabled within the Microsoft 365 app. So there's no user action required, to really like switch on those or to switch off those. It's just there with the Microsoft 365 apps. So there's no user action needed. The only admin action, like I said, needed is, again, if they want to give us the location information, they have to go and enable the location services. And, that's something they will have to switch on at the tenant level, which is a pretty easy thing to do. But that's the only admin action as well. If the admin doesn't take that action, then, again, it's not a deal breaker. We'll use the network egress or the network perimeter location to still show them all the information that I just showed you. So to summarize, I think there is no admin action needed if to view all of this. If you want, you can share the location information. That's the only action needed from the admin. On the user side, again, there's no action needed, but you can always use the standalone tool by going to that web page directly. And you can run that anytime if you think you are experiencing issues and you want to share that with your tenant admin.
Got it. So these insights are still collected out of the box in the tenant. There's nothing need to be enabled from a
Absolutely
tenant and admin perspective. Awesome. And is there anything that you could tell us a little bit more about, anything that's baked in on the client side? So you talked about tenant admin side, but for example, like Teams, if I look at Teams, I think of it as the most maybe latency sensitive and bandwidth intensive app. So is there anything that's done for Teams specifically for the Teams experience, or is that outside of the scope of this?
Well, we do run tests for Teams, and we show the jitter packet loss and the UDP latency. So that's something that we do. But like I said, I mean, this is not about real-time troubleshooting. So if the user is having a problem right now, this is not something useful, right, to do some real-time troubleshooting or debugging. Whereas this gets reported to the admin over a period of time, because all our aggregations are updated every day. So we run the aggregation every day, and the aggregation is really based off last 3 days of data. That's something I should have called out, so I'm just calling it out now. So which means an admin can look at, let's say, the impact of a network change somewhere between 24 to 72 hours range in the admin center. So the admin center is really useful to look at changes or the impact of changes over a period of time. The standalone connectivity test tool is something that the user can absolutely run. If they think they are having problems with Teams, they can go and run the tool. But that's something that's useful for the user to do. But other than that, I think they don't have other capabilities to do some real-time troubleshooting, if that's the intent of the question there.
Yeah, so what I really meant was like, if is it broken down by the different M365 applications within the admin center tool, that the experience for Teams is better than maybe
Yes.
OneDrive or something like that?
Yes. So the assessments are presented per workload. So
I
we do
see.
present it for Exchange, SharePoint, and Teams, and we also now have Microsoft 365 Copilot in there. So those are the 4 workloads by which we present the assessment for you. Yes. So your Teams can be worse than your SharePoint, or your SharePoint can be worse than your Exchange. So you should be able to differentiate that.
Awesome. Thanks. Thanks, Roshan. Great presentation. Sure. Thank you. Yeah.
All right, and actually that last question, I think, or maybe Roshan's last response, kind of segued nicely into what we're going to talk about next, because one of the key differentiators between the data that's presented to tenant admins and the admin center and the sort of longitudinal view over time is I think the big differentiator between that tooling and technology and what we're going to talk about next in informed network routing, which is much more near real time. So let me quickly go over this technology integration that we've made available for our ISV partners. And this will be the last section in today's talk, and we'll close it out from there. So informed network routing is a data sharing platform that we make available for consumption by SD-WAN partners with the consent of tenant administrators who want to opt into this feature. And the way to think about it is that it's sort of built on 3 different pillars: optics, feedback, and intelligence. So when we think about what we're providing, the primary data that we provide back to the SD-WAN partner is a set of optics that describe the real-time or near real-time experience that users in a given location are having with the 3 primary workloads that make up Microsoft 365, being Exchange, Teams, and sort of the combination of OneDrive and SharePoint, and specifically providing metrics that matter the most to the experience for those applications. For example, Exchange cares about latency. SharePoint cares about throughput. Teams cares about sort of the combination of latency loss and jitter. And so we're measuring those specific things, and we're measuring those based on actual data plane traffic. In other words, where what Roshan described in his overview of the tooling that we provide through the admin center, that is very much about synthetic actions being performed against the service that we use both for that as well as for kind of monitoring the health of the service, regardless of whether a user is actually doing anything within a given workload at any point in time. With informed network routing, what we're actually doing is looking at the real transactions that users from a location are performing. So this would be things like media streams that are associated with Teams, or accessing content on a OneDrive site, or sending mails, or browsing through a mailbox with an Exchange. And we're actually reporting on those metrics with this technology. So we provide kind of an aggregated view within a given time window back to the SD-WAN provider, and that can be used for a number of purposes that I'll get into in a second. So the second pillar is around feedback. So in addition to just having the raw metrics that describe the experience, we're also providing some scores, and these are provided on a per location. Actually, it's even more granular than that, per circuit, and where we define a circuit as a specific path out of a customer location to the internet or to Microsoft. So per circuit, per location, and per workload. And the scores effectively are describing whether, from Microsoft's perspective, that connectivity is okay, degraded, or bad. And the way in which we make that determination really kind of goes into the third pillar here, which is around intelligence. But I want to describe the purpose of providing that feedback first. So in addition to just providing sort of these generic optics that describe performance that you could then, within a user interface, provide some pretty graphs around, and perhaps trend over time to understand how things are going. When you're building an SD-WAN infrastructure, you'll typically have multiple paths to the internet from any given location. You could have 2 internet circuits. You could have, one path that goes directly out to the internet and one that backhauls through a regional data center. Lots of different flexibility that becomes enabled with an SD-WAN fabric sitting on top of whatever your underlay transport is. And given that you're going to have multiple paths to take to manage this SaaS traffic coming out to Microsoft. So what we're trying to do here is provide additional feedback to the SD-WAN solution above and beyond the typical sort of generic probing behavior that these platforms do already, to detect hard problems that are hard to detect with a traditional probe. Most of these solutions are going to be doing ICMP or simple HTTP probes against a particular set of endpoints. And if they discover that something is hard down, well, they're obviously going to fail that link and they're going to cause traffic to be routed in a different direction. And that's fine for sort of those obvious failure scenarios. However, we've found through research, both on our own as well as working with some of these partners, that things like bandwidth contention actually don't show up all that well when you're looking at these sort of simplistic probes. Additionally, if you're just running HTTP probes against an endpoint, degradation in UDP traffic transmission across a given path often won't show up, which will impact something like Teams media streams. And so this additional level of feedback that we can provide based on actual application experience in near real time provides a great benefit to making a choice about the best path to use to send a particular set of traffic at any given point in time. And then just to close out on that last pillar, the intelligence pillar, we are leveraging both sort of the traditional way of looking at evaluating the health of a traffic path, where you might have some kind of static thresholds and say, like, the acceptable latency for a given application is X. Well, that's fine for some cases, but what we found in the real world is that the ability to actually hit some of those targets in different regions around the world or through different types of connectivity varies greatly. And we have visibility into what is realistic for a given location, primarily coming from some of the data that Roshan was referring to earlier, or that we collect for all of our customers around the globe. So we use that to actually determine, for a given customer in a given location connecting to Microsoft with a particular type of connectivity, is this actually good or bad? And we also have some machine learning models that we constantly train, particularly on the team side, to understand, for that combination of latency loss and jitter, is this acceptable or not? Because those three metrics play against each other in interesting ways, and it's hard to evaluate each one of them as a singular metric. So that's the intelligence pillar, and we constantly update those models and ways of evaluating the scores as a result. So this feature is actually available free on the platform for anyone who can take advantage of it via an integrated SD-WAN solution. There's no additional sort of SKU required or offer required on the Microsoft side. I mentioned that we support the 3 major workloads in the suite. And today, in terms of availability, the only SD-WAN solution that's actually reached general availability here is the Cisco iOS SD-WAN solution. We are working with a number of other partners to bring them on board, and we'll make announcements over time around that. But Cisco absolutely is available today and can be leveraged by anyone just by opting in. So I'm going to quickly describe the opt-in experience, and then we'll close it out. So there's actually 2 opt-ins that are required. One is on the Microsoft side, one is on the Cisco side, or the partner side, I should say. Cynthia, go ahead. Got a question?
Yes, thank you. I was just wanted to ask, so today this feature is available for Cisco SD-WAN. What would it require from the other partners to be onboarded? Some work with you, or is it just on their side and about having the right image that can do all the polling, etc.?
Yeah, that's a fair question. So for partners who are interested in onboarding, there's a sort of a business aspect of this that requires kind of an agreement that outlines, how we protect each other's data and how we, how we kind of manage the integration process at a business level. There's no cost to it or anything other than, we just need to have something on paper that describes, jointly how we protect our customers' data and how we ensure that we're managing this together as an end-to-end solution. In terms of the actual integration, it's a fairly straightforward process with a set of API documentation that we provide, and it's really just providing access to a data sharing location where we kind of jointly exchange data bidirectionally that helps enable the solution that I'm describing. So it's partners can reach out to me if there's interest in onboarding. And we can evaluate whether or not that makes sense.
Yeah, thank you.
Sure.
Thank you. Yeah,
So,
makes sense. Sorry, I have another question.
Yeah,
so
go
for
ahead.
Cisco SD-WAN and for Cisco SD-WAN customers, is that a popular option, and is it widely used?
That's an excellent question. So we have hard for me to answer the popularity question because I don't have great visibility into the breadth of how many deployments exist on that particular platform. I only have visibility into kind of the raw number of customers who've opted in. I would say that from Microsoft's perspective, I think we are hopeful that we will see much more growth over time. It's I would say lightly used at this point. And we've got some great feedback from customers who have not yet opted in on that platform in terms of kind of the friction that's prevented them from doing that. And actually what I'm just about to talk about is the primary friction point. So I'll jump into that and explain what we're doing to help make that better. But at the same time, we've also gotten some great positive feedback from the customers who have opted in. So it's been well received. So in terms of the opt-in process and the way it's configured, because this is about sharing data both from the Cisco side to, I'll make it more generic, from the partner side to Microsoft as well as the Microsoft side back to the partner. We ensure that customers are doing this, kind of eyes wide open. So you have to enable it on the Microsoft side, and you have to enable it on the partner side to start that data sharing process. And then the primary way that we actually identify this traffic is based on the egress IPs that are associated with each individual branch circuit. And I'll walk through, kind of what that looks like visually very quickly. So in the same location that Roshan was referring to earlier in the admin center, there's an options tab that shows up at the top of the screen, which unfortunately is now hidden on this page, but it's right behind where SD-WAN solution shows. And one of the options there is the SD-WAN settings. And that pops open this little flyout box here that describes INR and allows you to click a button to actually add the SD-WAN solution. You pick which solution you have. The Cisco solution would show up here as well as any others that have reached general availability. And you pick a location around the world where you want to enable that data sharing to occur. And we have multiple locations around the world to meet compliance requirements for our customers. And that's a tenant-wide setting that you would make there. And there's a checkbox here that where you're acknowledging what specifically this means. And then there's a process of granting Entra ID application access for the application that the partner is running on their end to access the relevant tenant data within the Microsoft infrastructure that you grant here. And then that's it. That's the opt-in process to turn things on the Microsoft side. The other configuration is actually on this individual locations. We need the egress information, the egress IPs. And from the partner perspective, we'll often need something like the, in the Cisco case specifically, they use a system IP value to be a unique identifier for their branches, for their branch infrastructure. Each partner would have something similar. That information needs to be added into this portal, as well as optionally, you can turn the feature off on a per location basis as well. And so there's a configuration aspect on a per location basis that needs to be input in order to make this work. And this is really that onboarding friction that I was mentioning earlier. So we're actively doing some work with the partners that have already released and are in the pipeline now to allow them to actually manage all of these locations on their own. So you could think of this as, rather than Microsoft sort of automatically trying to detect these locations and then having a tenant admin having to come in and manually adjust those to reflect reality, and then also add in this additional information necessary to make INR work. Instead, what we'll have an option here where a tenant admin can say, I don't want to do all that. Cisco or the other partner, whoever's integrated here, already has that information because it is my SD-WAN fabric. Let them take ownership of that. And at that point, the partner would just effectively wipe out the location information that's here and manage it themselves. They would create locations that reflect the SD-WAN fabric, and they would manage those on an ongoing basis. So any changes in IP addresses, any changes in data path, which is reflected here as circuits, would automatically be updated. And that's a sort of coming soon item. We'll get that out the door shortly. So that's really the only configuration on the Microsoft side. Everything else really happens within the partner solution. So all of the visualization of the metrics that we provide, the controls in terms of automatically using the feedback to cause failovers between different data paths, that all shows up in the individual solutions. And I think in future videos we'll have some demos that describe or demonstrate exactly what that looks like for those solutions. But on the Microsoft side, it's really just about that initial configuration and opt-in. So 3 quick points here, in addition to the location config information I mentioned. So today we're doing what we refer to as composite egress disambiguation for only one of the workloads. And what this means is, if you have a complex path coming out of a branch, for example, you've got 2 branches and one of the paths out of those branches is going through a regional data center, we have some ability to actually figure out which branch the traffic actually originated from before it egressed out of the regional data center. And this is important because it helps us, again, provide that feedback back to the SD-WAN partner about which branch might actually be experiencing a problem with the portion of the path between the branch and the regional data center. Today, that's only implemented for Teams, and we'll be looking at finding some creative ways to implement that for the other workloads in the future, but it is there for Teams today. We also, recognize that with the move to remote work, that the concept of a traditional branch has become less meaningful to many of our customers. This is very much about, talking about the experience within a traditional branch. And so we're trying to figure out over time how we provide similar functionality that's more relevant to the notion of remote work within the structure of this feature. And then the other piece is around time window reduction. So today we provide feedback in 10-minute windows. So the sort of earliest that a SD-WAN solution could actually leverage the feedback that we're providing would be, on the order of roughly about 15 minutes after a problem potentially occurred. We want to reduce that so that we can be much more effective about kind of self-healing within the SD-WAN fabric. So that's sort of the coming soon and envisioned future investments in this space. So that I'll quickly summarize. we built these connectivity principles that we hope are easy for our customers and our partners to understand, to help align to the investments that we're making on the Microsoft first mile. So again, we kind of meet in the middle and all enjoy the benefits of the investments that our customers and partners make in the middle and last mile. Provide some great tooling to help folks understand how the changes that they make to better align to our recommendations are actually impacting the experience that their end users are having. All that shows up in the Admin Center reports that Roshan walked through. We've got that great network connectivity test tool that allows end users to kind of self-diagnose issues, and again, helps in many cases with that remote work scenario as well, where someone might be, like I am right now, working from their home office and not in a traditional branch, and might be experiencing a problem that I need help with. And then we've got this great functionality, this great integration with some of our SD-WAN partners to help enhance their solutions and also encourage a better end-to-end experience with Microsoft's products through informed network routing. So we've got a resources slide here if you're interested in following up on any of these other items. And with that, I think we'll close out today's session.
Excellent. Thank you, Jeff. Thank you, Roshan, for joining us and sharing some great insights. I personally learned a lot about these network tools that are available. We really appreciate your time. And Cynthia, any closing thoughts from you?
No, thank you. Very, very clear and interesting to see that we have like good solutions now for SD-WAN integration to M365 services.
Excellent. Thanks, everyone, and we'll see you in the next video.
Thank you, everyone.
Thank you.